Hello Year 11. For this lesson we're going to do an experiment, we're going to do an investigation into the half-life of a radioactive substance. Now we've learned about radioactive decay. It's when a certain radioactive atoms come apart and give off alpha, beta or gamma radiation. And it's random, remember? But you can work out something called half-life. And that's what this experiment is all about, finding the half-life of a radioactive substance. Now, obviously we can't use real radioactive substances, but I've got an experiment, something that will work just as well using a bag of sweets. Okay, so you need either M&Ms or Skittles, something that has got the letter on the top, and you need 100. So a small bag's probably not quite enough. If that's all you've got, that's fine. Do it with a small bag. But this is 125 grams. And if you can count yourself out 100 M&Ms, any kind, or the Skittles, and you need a cup, any cup. All right, so get those things ready. Okay, so you've got your Skittles, you've got your cup. The next thing that you need is the results table. Now you've got two choices. You can either print off the sheet, the Google Doc that I've shared with you, or if you haven't got a printer, it's absolutely fine. Just copy the table into your book, into your physics book, into your notebook, okay? And we're going to be following this method, working through the experiment and writing the results in our table, okay? So instruction number 1 of the method then says count out 100 sweets and put them in the cup. So tip your M&Ms out and count 100 into the cup. Okay, so I've got 100 in a cup. Step 2 says shake the cup and gently throw the sweets out onto the table. Okay, I'm going to reposition the camera so you can see this. Gently, oops, lost one, throw them out onto the table. Now you want them to land like this so they're not in a heap, ideally. And then it says look for the sweets which have landed with the M or the S facing upwards. So we're going to remove all the sweets which have landed with the letter facing upwards and put those to one side. Okay, so all the ones with the letter facing upwards, these are the ones, we're pretending these are the ones that have decayed. They're the atoms that have given off alpha, beta or gamma. Okay, watch out for the yellow ones, it's difficult to see the letter from those. Okay, and it says, step number 4, count these remaining sweets and record the number in your table. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 44, 46, 48. And I'm going to write 48 here in my table. Okay, so that's my result for throw number 1, 48. Okay, so all those that have decayed go to one side, and these that haven't decayed, they're the ones remaining when I got rid of all the M's. These that haven't decayed go back into your cup. Okay, so that 48 go back. Now, repeat steps 2 to 4 another 9 times. It might not take you that many times, but this is throw number 2. Tip them out again. Get rid of all the M's, because these are the ones that have decayed. And count those remaining. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 27 remaining. And I'm going to write that throw number 2 in my table. Okay? So this 27, push those to one side, I don't want those. These remaining 27 go back in your cup. And you repeat the process. This is throw number 3. Take out the M's. Is that an M? Some of them, the letters aren't very easy to see. Okay, and for throw number 3, I've got 2, 4, 6, 8, 10, 12, 14, 16 remaining. And I'm going to carry on like that, either until I run out of sweets or until I've done it 10 times. However, there is one thing to watch. When you just have a few left, occasionally when you tip them out, none have decayed. So let's say you had 4 last time and you've got 4 again. Well, in that case, you write down 4 twice, all right? So 4 will repeat itself and pop them back in. Oh, one's decayed. So it'll be 3 for the next time. And this is what tends to happen towards the end of your experiment. So you keep going either until you get to 10 or until all your sweets have decayed. Okay, so these are my results. It didn't take me 10 goes. Can you see on the 7th and the 8th? On the 8th throw, that last one didn't decay, so I recorded the number 1 twice, and then finally that one did land on the M, and I wrote 0. So those are my results. Okay, the last stage on the method is to get 3 other people to do the experiment. So you can, if you don't have 3 people in your family to do this with you, you can repeat it 3 times. But you need a full set of results now, 4 attempts at this experiment. And then add them up for the final column. Okay? So totaling them up then, I'm going to work across the top row. Get your calculator. There's no need to be doing mental maths here. 48 plus 54 plus 44 plus 50 equals 196. I'm writing 196 in that last column. So just make sure you're finding the total and not the mean. We're totaling them up across the rows, okay? Okay, so those are my total results, and they're the results that you're going to need for the analysis. So go to the Google Sheets, that's the one with the green tab, and you'll see there's a table where you type in your results. And as you type them in, the graph just does it for you. So once your graph is complete, you need to use the graph to work out the half-life and to answer the questions. Okay, so if you look at the graph, we're going to try and find how many throws it takes to go from 400 to 200 sweets in the cup. That means that the number of sweets in the cup has halved. So you look along the graph at 200. See where I've drawn the red dotted line? Until it touches the curve. And then draw or imagine a line, follow a line down onto the number of throws axis. And you should be able to see this is a little bit over 1, I think. It's maybe 1.1. Okay, so I hope you enjoyed doing this experiment. Type up your answers onto your Google Doc and hand it in. Any pictures that you want to add or videos along with it would be brilliant as well. Thank you. Bye.